So we are going to talk about concave mirrors, and in general we'll talk about curved mirrors, but today we're talking about concave. And so a concave mirror is one that looks like this, where you have a curve like this, and the reflective part of the mirror is actually on the inside of the curve here. So I have that drawn, I have our optical axis set up, I have our focal point and our object. So in general, when we're talking about curved mirrors, we're going to assume that we are looking at the portion of the mirror that is parabolic. And what this means is that what we're looking at a very small sort of section of the mirror where the radius of curvature of the mirror doesn't really affect our light. And in principle, what this means is that any light rays that come in parallel to the optical axis will be reflected through the focal point, okay? And we'll see an example of that in just a second. And that's sort of an assumption that we will use also with convex mirrors. What I'm going to do today is I'm going to show you again 3 rays that you can draw to help you figure out where an image is located for a concave mirror. So we'll start with our object here, this little arrow, and we're going to start with the tip of the arrow. We are going to draw a light ray parallel to the optical axis, and this is going to show us what I was just talking about with the parabolic approximation. So we'll send in a light ray parallel to the optical axis, it hits the mirror, and any light rays that are parallel to the optical axis will be reflected through the focal point, so we can draw that there. That is our reflected light ray. There's one light ray. We can draw another light ray where we actually go through the focal point, and when you have light rays that go through the focal point, they'll be reflected parallel to the optical axis. So again, we can draw through the focal point there, and then this is reflected parallel to the optical axis. So right away we have an intersection point, but we can draw one more ray just in case. Sometimes you might want more rays just to be sure. And we're going to use the law of reflection here. So when you have a light ray that comes in and it hits the center point, it will be reflected back at the same angle that it was incident on. So just like that. And then this light ray will be reflected at the same angle. So it'll look something like this, right? So this angle here is the same as that angle there, theta I, theta R. And we can see that just about this point is where they all intersect. So we can draw our arrow like so, and we see that it is flipped over, inverted on this side of the mirror. So concave mirrors will always in general have positive focal lengths. This object here, remember of the difference between a virtual and a real image. So in this case, light rays are actually traveling to this image location, so this is a real image. And what this means is that this is a positive image distance. Right, so this distance here from the object to the mirror, this is the distance of the object, and we can draw a similar one for the image. This is getting a little cluttered, but this one is the image distance. And we can actually write down, this is just a matter of doing some geometry, a similar equation as the thin lens approximation that we can use for curved mirrors, where we can say 1 over the distance of the object plus 1 over the image distance is equal to 1 over the focal length. So this same equation applies to this case here where we have a concave mirror, and that is how you can use ray diagrams to figure out where an image is located for a concave mirror.